Okay, so from the last video, sorry about that, it's 1 minus cosine of theta all over sine of theta, which is also true of plus or minus the sine of theta all over 1 minus cosine theta, right? And you can't forget the plus or minus because of this A, S, T, C thing, right? Let's try out the quadrants. So A right here, S right here, T right here, C. Meaning all trig functions like sine, cosine, tangent, cosecant, secant, cotangent, right? And all the sine functions here, which are sine and cosecant. And all the tangent functions here, which is tangent and cotangent. And all the cosine functions right here, which is cosine and secant, right? Thank goodness we're not finding any cotangent, secant, or cosecant of any of these kinds of values when we use trig identities. So I'm going to use the sine formula. I'm going to use the sine identity of theta over 2, which is this, to solve for sine of pi over 8. All this really is just sine of u over 2, right? Which is equal to plus or minus the square root. Now you got to be careful here, because this is 1 minus the cosine of what u over 2 all over 2, right? So let's say this, u over 2 is equal to pi over 8, right? I multiplied both sides by 2. These 2's cancel, so that u gives me 2 pi over 8, which is really pi over 4. And now this trig identity makes it pretty simple for you. And this is the sine value of this. But if it's pi over 8, I can check by just drawing my unit circle and see where pi over 8 actually falls, right? Well, see, this is pi over 6 right here. And pi over 12 would fall somewhere right here. Pi over 8 would be here, so this would be quadrant 1, right? So this, is going to be positive. So in order to find the sine of pi over 8, I'm just going to do the positive square root of, fix my square root sign there. And I got 1 minus the cosine of pi over 4 all over 2, right? And then I just simplify. So I get the square root of 1 minus the square root of 2 over 2, which is indeed the exact value of the cosine of pi over 4. All of that business over 2. And we're now in a complex fraction situation here, so we multiply top and bottom by 2, right? And that's going to give me 2's cancel here. And I got to be careful because this whole entire thing is being multiplied by 2, right? So you got the square root of 2 minus the square root of 2. 2 times 2 is really 2 squared, and that gives you 4, right? And then to simplify this down even further, I can do the square root on both the top and the bottom, because the square root also goes with the bottom too. You got to be careful of that. So I've got a square root of 2 minus the square root of 2. And the square root of 4 you can take evenly as 2. So the sine of pi over 8 is going to give you the square root of 2 minus the square root of 2 all over 2. Right? See? That's why the half angle identity makes it easy for you. And now the cosine of 3 pi over 8. So 3 pi over 8, that's slightly less than pi over 2. And pi over 2 would be right on the y-axis. So it would be about right here. Right? And this gives you about 3 pi over 8. And this is also quadrant 1. So this is obviously going to be the positive square root because all 6 trig functions are positive in quadrant 1. So this, if I solve for u here, u over 2 is equal to 3 pi over 8. Multiply each side by 2. Cancel those out. And I'm just multiplying in the numerator, so I get u equals 2 times 3, which is 6 pi over 8, and that reduces down to 3 pi over 4. And all we're just doing is using the cosine value, the cosine identity this time, which is that plus or minus, but it's only going to be in the plus due to quadrant 1. And this time I'm doing 1 plus the cosine of that value of u divided by 2. So when we're taking the cosine, we are taking the square root of this time 1 plus cosine of 3 pi over 4 all over 2. And we got to simplify this. So this is equal to, open up another square root symbol, we get 1 plus, and the cosine of 3 pi over 4, recall, so we have pi over 4 right here, 1, 2, 3. And recall on the unit circle that this right here, and remember sine is equal to y, cosine is equal to x. So this is really 1 plus a negative square root of 2 over 2. Right? Because the cosine value would be negative in quadrant 2. And according to the trig identity, that's all over 2 inside the square root. And then a plus and a minus, you know, is going to become a minus, right? Because I'm just going to rewrite this. So square root of 1 minus root 2 over 2, all over 2. Multiply both top and bottom by 2. You can say this is 2 squared, by the way. And then the 2's cancel in the numerator. And we're left with the square root of 2 minus root 2 all over 4. So then this can be said as the square root of 2 minus another square root inside a square root of root 2. And then the 4 square roots evenly is 2, right? So this is also the square root of 2 minus square root of 2 all over 2, right? And 3 pi over 8, by the way, is indeed in quadrant 1. Tangent should hopefully be a little easier. And we're looking for the tangent of 5 pi over 8. So, looking at our trig identity, I can arguably use any one of these, but if I have 5 pi over 8, say it's like 1, 2, 3, 4, 5, we are in quadrant 2 this time. And in quadrant 2, it only says that only sine functions are positive. So tangent is obviously going to be negative in quadrant 2. But first, let's solve for our u. So we have u over 2 equals 5 pi over 8. The same is true even when you do the tangent function. And then we multiply each side by 2. 2's cancel. 8 and a 2 can be a 4 and a 1. And that's just really 5 pi over 4. Dang, I keep forgetting about cross-canceling. And so, if we're in quadrant 2, only the sine function can be positive, so the tangent has to be negative. So we have the negative. I'm actually going to do this first one up here, which is 1 minus the cosine of 5 pi over 4 all over the sine of 5 pi over 4, right? Okay. So 5 pi over 4, that would be 1, 2, 3, 4, 5 in quadrant 3. So these are both obviously going to be negative because only tangent functions can be positive in quadrant 3. So I know for a matter of fact that this will be negative 1 minus square root, negative square root of 2 over 2 perhaps. And it's all over negative square root of 2 over 2. Because both sine and cosine are going to be negative in quadrant 3. A double negative become a plus, right? And I got to simplify this because I've got a complex fraction. I can multiply 2 on both top and bottom, right? And I get a negative. And you got to be careful. This 1 also goes with this 2. I've got negative 2 plus the square root of 2 all over the square root of 2. But some teachers don't like it if you don't rationalize your denominators. So how to rationalize your denominator? You just times square root of 2 over square root of 2. And then you multiply this whole entire thing in the numerator. So you really get 2 negative. Got to watch that negative sign. 2 root 2. And root 2 and root 2 are just going to cancel the square root out. And it's just going to be 2. All over 2. But hey, this can be reduced down. These all become 1s. So you really have negative 1 plus square root of 2. After all. So the tangent of 5 pi over 8 is negative 1 plus square root of 2. And there you go. Half angle identities.